Chapter 5, Section 5, we're going to derive our double angle identities. Let's start with cosine of 2a. This is a double angle because this is twice angle A. All right, so what is this equal to? To derive this, I'm going to have us consider writing this as cosine of a plus a. After all, a plus a is 2a. And I'm having us consider writing it this way because we know how to expand cosine of a sum, right? Because we have a sum identity for cosine. By the sum identity for cosine, this would be cosine of a times cosine of a minus sine of a times sine of a. This is the sum identity for cosine. So therefore you have cosine squared of a minus sine squared of a. So there you have it. There's one identity right there. I'm going to change the color for us. One identity is cosine squared, cosine of 2a rather, is equal to cosine squared of a minus sine squared of a. Now, let me tell you this. You're going to have three different variations or three different double angle identities for cosine. This is just one of the three, all right? So you're going to have three different versions. Now, watch this. Working from this statement, we can say that cosine of 2a, which is equal to cosine squared of a minus sine squared of a, let's substitute cosine squared of a with 1 minus sine squared of a. We know that's true by one of the Pythagorean identities, right? Or actually, the Pythagorean identity, okay? Cosine squared of a plus sine squared of a is equal to 1 basically leads to cosine squared of a is the same as 1 minus sine squared of a. Here, if you don't believe that, allow me to, just a side note here, I want to prove to you cosine squared of a plus sine squared of a is equal to 1, correct everybody? That must mean that cosine squared of a is the same thing as 1 minus sine squared of a. So this is the substitution I just made. I replaced cosine squared of a with 1 minus sine squared of a by the Pythagorean identity. Okay? All right, I'm going to erase this now because that was just a side note. So what we have now here is cosine of 2a is 1 minus sine squared of a minus sine squared of a, which leads us to the second double angle identity for cosine. Cosine of 2a is also equal to 1 minus 2 sine squared of a. Okay? So now you can see you have two different identities for the double angle identity for cosine, right? Two different expansions, I should say, for the double angle identity for cosine. Cosine of 2a is cosine squared of a minus sine squared of a. It's also 1 minus 2 times sine squared of a. Now there's one more, okay? Again, coming from this statement here, okay? Let me go back to that. Cosine 2 of a, which is equal to cosine squared of a minus sine squared of a. What we can do this time around is replace sine squared of a with 1 minus cosine squared of a. Okay, so then this is equal to cosine squared of a minus 1 minus cosine squared of a. Again, by the Pythagorean identity. If you're doubting this, that sine squared of a is 1 minus cosine squared of a, start with cosine squared of a plus sine squared of a is equal to 1 and solve for sine squared of a. You'll find that sine squared of a is equivalent to 1 minus cosine squared of a. So then we're seeing that this is the same thing as cosine squared of a minus 1 plus cosine squared of a. All right, so here's our last one. Cosine 2 of a then is the same thing as 2 times cosine squared of a minus 1. So what I've highlighted in green here are three different double angle identities for cosine. Now, what would be really good at this point is to derive the double angle identities for sine and for tangent. So let's go for sine next, okay? So sine of 2 theta, or 2a, I guess we're saying a right now, whatever. Let's use the same strategy. So let's write it as a plus a, that's 2a. And then let's use our sum identity for sine to expand this. So then this would be sine of a times cosine a plus cosine a sine a, which is basically 2 times sine a cosine a. All right, done. That one's done. So sine of 2a, just as a kind of in summary, sine of 2a is 2 times sine a cosine a. All right? There's only one double angle identity for sine. Let's go for the double angle identity for tangent. Same kind of deal, everybody. Tangent of 2a. Let's write that as tangent of a plus a, which by the double angle identity for, or by the sum identity, excuse me, for tangent, this would be tangent of a plus tangent of a over 1 minus tangent of a times tangent of a, right? That was a sum identity for tangent that you and I derived a few lessons ago. So then this would be, in the numerator, 2 times tangent a. In the denominator, 1 minus tangent squared of a, like that. So in summary, tangent of 2a is equal to 2 times tangent a over 1 minus tangent squared of a. All right? And again, there's only one identity, one double angle identity for tangent. One double angle identity for sine, one double angle identity for tangent, but 3 different double angle identities for cosine. Okay, guys, I've given us all of our double angle identities for cosine, and then double angle identities for sine and tangent. Here's the first example. Given that sine of x is 8/17 and cosine of x is negative, find each of the following: sine of 2x, cosine of 2x, tangent of 2x. You're going to see me work through each one of these individually, all right? So here comes the first one. Let's find sine of 2x, all right? So this is part A, all right? So it's sine of 2x. Okay, sine of 2x is what we need to find, and by the identity, double angle identity for sine, we know that this is the same thing as 2 times sine of x times cosine of x. Okay, guys, we know what sine of x is. It's given, 8/17. We could just plug it in. But what you and I do not know is cosine of x. We do know that it's negative, but we don't know what it is. So what I'm going to do is I'm going to take the given information and find cosine of x so that I can plug it in here. All right? So this is what's given. What's given is that sine of x is 8/17. All right, so this is where I'm going to start. Cosine squared of x plus sine squared of x is equal to 1. That's the Pythagorean identity, okay? I need to find cosine of x. So I know cosine of x is the same thing as plus or minus the square root of 1 minus sine squared of x. So remember that cosine is negative. That's given to us. And it's equal to the negative square root of 1 minus 8/17 squared. Okay? So then cosine of x is equal to negative, what is this, 289 over 289. This is the number 1, right? Minus 64 over 289. Okay? This. So then cosine of x is equal to negative square root of 289 minus 64. 225 over 289. Square root of all that. So then cosine of x is equal to negative 15/17. Okay, now that I know what cosine of x is, I can plug it in to this expansion along with sine of x. All right, so let's do it now. Let me change the color for us. Okay. All right, cool. So let me move up as well. So sine of 2x is now equal to 2 times sine of x cosine x, which is 2 times, now sine of x, oops, I forgot my x. Sine of x is given to me, 8/17. Cosine of x, I just found it, negative 15/17. Once I do this arithmetic, I have found what sine of 2x is. All right, so then it is, let's see, it's all negative, and we got 17 times 17, so that's 289 in the denominator. And then the numerator, let's see, you can multiply in whatever order you want. 2 times 15 is 30. 3 times 8 is 24, plus that 0 is 240, right? So then this is what sine of 2x is, sine of 2x. I want to bring something to light here. What I see students do a lot of times, which is wrong, is they say, oh, okay, I need to find sine of 2x, and I know what sine of x is. Well, let me just double 8/17. And that's not true. Sine of 2x is not the same thing as doubling 8/17. You can, clearly see that now with with the answer that you and I got. If you double 8/17, here, let me write it down. If you double 8/17, you're basically doing 2 times sine of x, which is not the same thing as sine. Let me write that down. If you double 8/17, you are doubling sine of x, which is not equal to sine of 2x. These two things here are different, sine of 2x and 2 times sine x. So I bring this up because so many times students will just double that number 8/17 and think that's sine of 2x. It's not that straightforward. Okay, cool. Let's go for part B, cosine of 2x. Now remember, let me move this down a little bit so that we can see. Remember that cosine, the double angle identity for cosine, there's 3 different versions. So they want us to find cosine of 2x. It would be great if you and I can stick with the given information only. That is, sine of x is 8/17. How can I use sine of x to find cosine of 2x? Well, when I look at my 3 identities, this is the one that I want to use because this double angle identity for cosine only relies on sine of a, which is what is given to me. I know what sine of x is, right? Hey guys, don't get thrown off by it. This argument is a and this argument is x. It's the same thing here. I could have written this as cosine of 2x is equal to 1 minus 2 times sine squared of x, okay? So I want to use this identity because this identity on the right side of this is only the function value for sine, which is what I have, all right? Okay, cosine of 2x is what I'm looking for, and we know that cosine of 2x can be rewritten as 1 minus 2 times sine squared of x, okay? This is good news because we know what sine of x is. Sine of x is given as 8/17. And we need to square that. So then this is 1 minus 2 times 64 289ths, right? Which turns out to be 1 minus 128 over 289, which is the same thing as 289 over 289 minus 128 over 289, right? A lot of arithmetic here. So I believe what we get here is 161 over 289. And that's what cosine of 2x is equal to. Okay, guys, let's go for the third one now, which is tangent of 2x. Okay, I'm going to endeavor to use only the given information as much as possible, okay, everybody? By the double angle identity, this is, for tangent, this is 2 times tangent of x over 1 minus tangent squared of x. Okay, so what I need here in order to figure out what tangent of x is, I need sine of x. Well, that's good news, that's given. And I need cosine of x. But we found cosine of x earlier. So then this is given, oops, sorry about that. This is given, sine of x is 8/17. And cosine of x, we found that using the given information. So this is negative 15/17 from above. So that implies that tangent of x is equal to sine of x, which is over cosine of x, which is 8/17 over negative 15/17, right? That's a little sloppy there. 15ths like that. Which is equal to 8/17 times negative 17/15, which gives us negative 8/15. So then this is what tangent of x is equal to. I'm going to take this value for tangent of x, and I'm going to plug it in to my identity, okay? So then this is 2 times negative 8/15 over 1 minus negative 8/15 squared. Okay? So at this point, it's just some arithmetic, folks. So then this is equal to negative 16/15 over 1 minus 64 to 25ths. Okay? This is the same thing as, continuing the arithmetic here, negative 16/15 over, now the number 1 is the same thing as 225 over 225, so it's 225 minus 64 over 225, which is negative 16/15 over, what is this, 161 over 225. Okay, so then our final answer will be, let's see, negative 16/15 times 225 over 161. Okay, 15 goes into 225 15 times, like that. And so our final answer will be negative 16 times 15. So this is negative. So then this is 240 over 161. This is the function value for tangent of 2x. Cool. Good job, guys. All right, example 2. Find the values of the 6 trig functions of theta given that cosine of 2 theta is negative 12/13. And theta is between 180 degrees and 270 degrees. Let's just call this out. If theta is between 180 degrees and 270 degrees, then that means theta is in quadrant number 3. That's going to be important when we choose our signs, all right? All right, guys, here we go. Let's do this. We have this identity that cosine of 2 theta is equal to 2 times cosine squared of theta minus 1. That's one of our double angle identities for cosine. Now, we know the left-hand side. Cosine of 2 theta is given. It's negative 12/13. So I'm going to replace the left-hand side with negative 12/13. And then all I have to do now is solve for cosine. Let me add 1 to the left-hand side. When I add 1 to the left, that's 13/13. So you get 1/13, right? When you add 1 to negative 12/13. when you divide by 2, remember dividing by 2 is the same thing as multiplying by 1/2. So then you have 1 over 26 is equal to cosine squared of theta. Now remember, you're in quadrant number 3. In quadrant 3, cosine is negative. So by taking the square root of both sides and then taking the negative root, you would have 1 over the square root of 26, which is rationalized negative root 26 over 26. That's what cosine of theta is. All right, good job. Now we also need sine of theta. So I'm going to go back to our identity, the double angle identity for cosine. But this time I'm going to use the identity that says 1 minus 2 times sine squared of theta, like that, okay? And again, just like last time, we know the left-hand side, right? We know that cosine of 2 theta, by the given information, is negative 12/13, so that's what I replaced that with. And like before, this time I'm going to isolate sine of theta. I'm going to subtract 1 from negative 12/13. That's the same thing as subtracting negative 13 over 13, which would be negative 25/13. All right, is equal to negative 2 times sine squared of theta. I'm going to multiply both sides by negative 1/2. Multiplying both sides by a negative gives me a positive on the left. And when I multiply by 1/2, I get 25 over 26 is equal to sine squared of theta. Okay, guys, let's take the square root of both sides, gives you sine, right, of theta. But in quadrant 3, you're negative, right? So it's negative square root of 25 over 26. Okay? So then this is negative 5 root 26, which is negative 5 root 26 over 26. That's what sine of theta is. All right, the next thing we'll find is tangent of theta. But notice that, tangent of theta is by the quotient identity, sine of theta over cosine theta. Now, we have to be careful here just because sine of theta and cosine of theta are both derived pieces of information. So it is risky to be using derived information to find tangent theta. So I'm going to be careful to make sure my work is correct. So the numerator is 5 root 26 over 26, right? That's what sine of theta is. And then cosine of theta we found already to be negative root 26 over 26. Okay, cool. Definitely a negative divided by a negative is a positive. We know that because theta is in quadrant 3 and tangent's positive there. So then you're going to have 5 root 26 over 26 times the reciprocal, which would be 26 over root 26. I'm not even bothering with my signs here because I know a negative divided by a negative is a positive. So these divide out, and so do these. And so tangent of theta is just 5. Okay? Okay, guys, this is what we found so far. The instructions said find the values of all 6 trig functions. We could find the remaining 3 by using reciprocals. That leads us to secant of theta is negative root 26. Cosecant of theta is negative root 26 over 5. And cotangent of theta is 1/5. All right. Good job. Okay, example 3. Verify that this is an identity. All right. This is where you and I choose a side to work with. I'm going to choose the left-hand side, okay? You can choose whatever side you want. Usually we choose a side that looks more complicated and make it look like the other side. Okay, so we have cosine to the 4th power of beta minus sine to the 4th power of beta. And somehow we're going to try to make this look like the right-hand side, which is cosine 2 of beta, cosine of 2 beta. All right, the left-hand side is a difference of 2 squares. So therefore it factors like this. All right, cosine squared of beta plus sine squared of beta times cosine squared of beta minus sine squared of beta. All right, this first factor here is your Pythagorean identity, which is equal to 1. And then over here, this is this here, this here is one of your double angle identities for cosine. So then this is cosine. I guess I didn't really want that color. Hold on. There we go. Cosine of 2 beta. And this is cosine of 2 beta, which is the right-hand side. So we made the left-hand side look like the right. Cool. And I'm sure there's more than one way to do this problem, but this definitely works. Let's go to the next example. All right, example 4, simplify each expression. The first expression they're going to want you to simplify is 2 times cosine squared of 5x minus 1. Okay. The next expression they're going to want you to simplify is sine of 165 degrees times cosine of 165 degrees. All right, we'll do with one at a time, of course. Let's go with the first one, part A. All right. Now, you have this identity that says cosine of 2a is equal to 2 times cosine squared of a minus 1, right? This is one of your double angle identities for cosine. So notice that they gave you an expression that matches this right-hand side. It matches, look at this 2, matches this 2, and then this argument, 5x, is like your a here. Here, I can label that. This here, cosine of 5x there, that's kind of like your a in your identity. And of course, the minus 1 is like the minus 1. Therefore, we can make this whole expression, which follows this pattern, look like the left-hand side. So the identity says all you have to do is write cosine of 2 times your a value. But in our example, our a value is 5x. So we're going to write 2 times 5x, which is cosine of 10x. So 2 times cosine squared of 5x minus 1 is the same thing as just cosine of 10x. Cool. Let's try this second one here. Let me see if I can section this off for us so that we don't get confused. Okay. Notice that we have something that looks like this. Your identity is sine of 2a is equal to 2 times sine of a cosine a. We almost have this. We almost have this expansion. Can I make this look more like an S right there? Let's see. Yeah, definitely. Notice that what they gave us almost looks like this. What is missing in what they gave us? What is it missing in order for it to follow this pattern? Isn't it missing this 2 right here? There's no 2 out front. Okay? So then what I'm going to do then is I am going to put the 2 there. So watch this. Sine of 165 degrees. Actually, let me move this over a little bit. Okay. Sine of 165 degrees. This is what they gave us. Times cosine of 165 degrees. Well, that what they gave you is the same thing as multiplying it by 2 and also multiplying it by 1/2, isn't it? Because 1/2 times 2 is what? Isn't this equal to 1? So if you multiply a given expression by 1, then you are not changing the value of the original expression. So what that does for us is this much right here definitely looks just like this right side, right? So then this whole expression inside these green parentheses, which matches this form, can be rewritten like the left, which is a sine of 2a. In this example, your A value is this 165 degrees, right? So then what we could do then is rewrite this as, you have a 1/2 out front, and everything inside the parentheses can be rewritten as sine of 2 times A, which is 2 times 165 degrees. Okay, so this is 1/2 of sine of 330 degrees. Is my math correct? 160 times 2 is 320, and then plus 10 more, 330. Yeah, so then this is 1/2 of sine of 330 degrees is negative, let's see, 1/2, right? Yeah. So then, therefore, what they gave us is the same thing as, or equivalent to, negative 1/4. Isn't that great that this given expression here is equivalent to negative 1/4? Cool deal. This next example is really important, especially when you are studying the calculus. So write cosine of 3x in terms of cosine of x. So they gave you a triple angle. Now, we don't have a triple angle identity, but this is a triple angle, and they want you to write it in terms of cosine of just x. Let's get started. This is going to be a fun example. All right, so cosine of 3x. What I suggest doing immediately is rewriting this as cosine of 2x plus x. I don't think anybody would challenge the fact that 2x plus x is equal to 3x. And now I would ask you to expand this using the sum identity for cosine. It would give you cosine of 2x times cosine of x minus sine of 2x sine of x. All right, cool. Then you want everything in terms of cosine of x, so I suggest you rewrite cosine of 2x as 2 times cosine squared of x minus 1. That's your double angle identity. Minus, now I suggest here you rewrite sine of 2x using the double angle identity for sine, which is 2 times sine x. It's hard to write neat sometimes with this pencil. All right, 2 times sine x cosine x times sine x. Okay, now what I suggest you do is, at this point, distribute cosine of x here. All right, and then over here, multiply sine x and sine x to get you sine squared of x. Okay, so then this is equal to 2 times cosine cubed of x minus cosine of x minus 2 times sine squared of x cosine x. Notice that all of this is done. 2 times cosine of x raised to the third power. This is in terms of cosine of x here, so that's good. This is cosine x, so that's good. That's what they wanted. This cosine x is good. Obviously, what's not good is sine squared of x. I'm suggesting that you replace sine squared of x with 1 minus cosine squared of x. That's one of your Pythagorean identities. So then this would be 2 times cosine cubed of x minus cosine of x, right, minus 2 times, now here it is, 1 minus cosine squared of x, that's the same thing as sine of x, times cosine of x. Cool, almost done. Now let's distribute cosine of x here, like that, okay? So then you're going to get 2 times cosine cubed of x minus cosine of x. Oh, you know what we should do? We can do this as well. At the same time that we're distributing cosine of x, let's distribute negative 2 at the same time. Okay? So we're distributing from the left and from the right. that would give us negative, let's see, negative 2 times cosine x. And then that would give us positive 2 times cosine cubed of x. Cool. Let's combine like terms. So you got 2 times cosine cubed of x out front, 2 times cosine cubed of x on the back end. So combining those two gives you 4 times cosine cubed of x. And then these two definitely combine as well. These two are like terms. So we can add those. And that gives us minus 3 times cosine of x. Whew, that was really good. This is going to be super helpful when you are integrating in calculus. This is going to be an important example for us. All right, cool. When we're done, we usually box our answers. Good job, you guys. Let's jump over to example 7. Actually, before we get to example 7 and example 8, there's a list of identities in your book. They are called the product to sum identities and the sum to product identities. Product to sum and sum to product. I would like to derive for you the product to sum identities, at least one of them. There's 4 different product to sum identities. I'd like to derive just one because all of them are derived pretty much the same way. All right? So let me derive one of them for you. Okay, so let's do this one. Imagine you have cosine of a plus b, and we know what that is equal to. It's equal to cosine of a times cosine of b minus sine of a sine of b, right? And then what if I asked you to add to that cosine of a minus b? Okay. Well, cosine of a minus b is cosine of a cos of b plus sine of a sine of b. These are identities, right? So what if I asked you to add? Okay, so I want you to add vertically here, this plus this, all of this plus all of that. Well, first of all, notice on the right-hand side, you would get negative sine A sine B plus sine A sine B. Those would cancel for sure. So then on the left, you would just have cosine of A plus B plus cosine of A minus B. And all of this is equal to the right-hand side, which is just 2 times cosine A times cosine of B. We're just about done. What I would ask you to do next is divide both sides by 2. Why? Because I want to isolate this product right here so I can show you what this product is equal to. So then this product, cosine of A cosine B, that's this product right here, folks, is equal to this whole left-hand side, which is cosine of A plus B plus cosine of A minus B. I could make this a better parenthesis there. Yeah, better. Cosine of A minus B. All of that divided by 2. This is one of your product to sum identities. One of your product to sum identities. This is a product. The left-hand side is your product, and it expands as this sum here. All of that. Pretty cool. The book actually writes this 1/2, this 2 as a 1/2 out front. In other words, the book writes it this way. It's the same thing though. Cosine of A, cosine of B is equal to, they write it as 1/2, and then they do times cosine of A plus B plus cosine of A minus B. It's the same thing that we wrote right up there, except instead of dividing by 2, they're multiplying by 1/2, which is the same thing. All right, so that's one of your product to sum identities, and they're all derived the same kind of way. Okay. Oh, if you would like to see that again, Well, obviously, you can rewind the video, but you can also look at pages 234 and 235 in your textbook. Okay, what I did for you is I wrote down all 4 of your product to sum. All the left-hand side are products. All the left-hand side are products, and all the right-hand side expressions are sums. So these are product to sum identities, and there's 4 of them. This is the one that you and I derived, and all of the other 3 are derived very much the same way. Okay, example 7 says, write the following as the sum or difference of 2 functions. Okay, write the following as the sum or difference of 2 functions. And it's going to be 6 times sine of 40 degrees times sine of 15 degrees. So they've given you a product and they want you to write it as a sum. They gave you a product, you write it as a sum. Okay, look at this and tell me which one you're going to use. Which one of these 4 identities are you going to use? Well, you got sine of something times sine of something else, so that's going to be this second one. Okay, where 40 degrees is like your A value and 15 degrees is like your B value. All right, this 6 just comes for free in the expression, okay? That they gave you the 6. I know you don't have a 6 out front here. It came with the expression, so you got to keep it. All right, so let's see. Here we go. I'm going to follow this pattern right here, folks. All of this on the right-hand side. Every time I see an A, I'm replacing that with 40 degrees. Wherever I see a B, I'm replacing it with 15 degrees. All right, here we go. The first thing I'm going to write, though, is this 6. I'm going to bring down the 6. Now, here we go. 1/2 times cosine of, and then we have A minus B, which is 40 degrees minus 15 degrees. All right. No, actually, I shouldn't have closed that parenthesis there, or that bracket. Okay, let's keep going. Minus cosine of A plus B. So it'll be 40 degrees plus 15 degrees. Okay. Now I can close off. I think I have 2 sets of brackets here that I need to close off. All right, guys. Out front, 6 times 1/2, that's just the number 3. Yeah. And then inside of here, we got cosine of 40 degrees minus 15 is 25 degrees. Okay. Minus cosine of 40 plus 15 is 55 degrees. Like that. Okay. So then this can be rewritten as 3 times cosine of 25 degrees minus 3 times cosine of 55 degrees. We did it. We rewrote a product as a sum. Now don't let this throw you off that they asked for you to write a sum and this is a difference. Actually, no, I take that back. The directions say write as the sum or difference. So this is a difference, so we're good. All right, good job. Okay, then you have 4 sum to product identities. Now these ones are pretty intense as well. They look pretty full, all right? A lot of things going on. But they're easily derived. I would invite you to look at pages 235 and 236 in your textbook. And they actually give you, they derive one of them for you. And all of the others are derived similarly. And then all 4 identities are given on page 236. Can you look at those? Can you even pause this video and go to page 235 and 236 and check that out? Okay, guys, this is the last example in this section. Write the following expression as a product of 2 functions, okay? As a product of 2 functions. This is what they're giving you. Cosine of 3 theta plus cosine of 7 theta. Okay, everybody, this is definitely a sum, and they want you to rewrite this sum of 2 functions as a product of 2 functions. Now, if you look at page 236 in your textbook, you will see which identity I'm about to use, okay? I'm going to actually write it down for us right now. This is it, guys. This is the identity that you and I are about to use to rewrite this sum as a product. So notice that you got cosine of A plus cosine of B is equal to 2 times cosine of A plus B over 2 times cosine of A minus B over 2. Now, when they talk about A and B, in this example, 3 theta would be your A, right? And then 7 theta would be your B value, right? When you apply the identity. Okay, guys, here we go. What we're going to do is, since they gave us cosine of 3 theta plus cosine of 7 theta, which looks awfully like this left-hand side, we're going to rewrite the given expression as the right-hand side, like this. Okay, so this is the pattern you and I are following. Okay, cosine of 3 theta plus cosine of 7 theta is going to be equal to all of this. Wherever I see an A, I'm replacing that with 3 theta, and wherever I see B, I'm replacing it with 7 theta. Okay, hopefully that's clear. So then this right here, cosine of 3 theta plus cosine of 7 theta will be equal to 2 times cosine of 3 theta plus 7 theta over 2 times cosine of 3 theta minus 7 theta over 2. Okay? So then this is equal to 2 times cosine of 3 theta plus 7 theta is 10 theta over 2 times cosine of negative 4 theta over 2. All right, let's just simplify. So then this is 2 times cosine of 5 theta times cosine of negative 2 theta. Now, you're not done, because remember this fact. This is an even-odd identity. Remember that cosine of negative x is equal to just cosine of x. Okay? So yes, this is one of your, this is called your even-odd identity. It's one of your even-odd identities, that cosine of negative x is cosine of x. This is because cosine is an even function. So in other words, this here, cosine of negative 2 theta, is just the same thing as cosine of 2 theta. So I should simplify that. So then this is 2 times cosine of 5 theta times cosine of 2 theta. Now you did it. You simplified as much as you could. This, let me see if I can go up a little bit here for you. This sum here has been rewritten as a product. Good job, everybody. Okay, this concludes 5.5 double angle identities. All right, so good luck in the exercise section of this in your textbook. And I'll catch you in the next video, which would be 5.6, half angle identities. Hey, by the way, 5.6, entitled half angle identities, will be the last section for chapter 5. Yeah, there's only one more section left. So make sure you are staying up to date with all your work. Only one more video after this one for chapter 5, and then chapter 5 will be finished. All right, guys, I'll catch you in the next video. See you later.